Hello, welcome to KAJOS Consultants. My name is Joshua, and today I'll be taking you through how you can analyze and interpret data from a one sample t-test. Remember, in our previous tutorial, we did some of the assumptions that you have to meet for you to conduct or to run a one sample t-test. And we said that one sample t-test is used to determine whether a sample comes from a population with a specific mean, and the mean for such a population is sometimes not always known, but in most cases it is hypothesized or assumed. So remember some of the assumption. If you want to get more of that, you can also visit the channel and check on the assumption, some of the assumptions that we tackled for that one sample t-test has to meet. And number one, we said that the measurement should be an interval or a ratio, and we say these are data that are continuous. For example, time can be marks of a specific exam or of a certain results. They can also be height or it can be weight of a specific person. Also mention that data are independent and they should not be correlated with each other, and there should be no significant outliers, something that I will demonstrate shortly. And fourth, the dependent variable should be normally distributed. So by the end of this session, we also need to know how to understand how you can run and interpret one sample t-test results. Here I have a sample data that I'm going to use for this particular exercise. These are data whereby a certain company wanted to adopt which gender should they develop a certain toy kit to be used for either girls or boys. So they had a certain type observed some of the duration which the population or the group of people selected took to play with this toy. So we have here the sex of the group, of the population, and also the time that which particular person took while using such a toy. So first of all, we said that our data has to be continuous, and in that case, interval or ratio. Time is one of the interval or a ratio scale data. The second one, this data, they are not independent on each other. The time that is recorded for the second person is not dependent on the time that the first person will take. And then the aspect of outliers value or extreme values, we can also observe. And that is also something that we are also going to test on this case. And the last one, the independent value should be normally distributed. So we can check some of the normal distribution for this data, and it is to check for normality for this particular data. You simply, I also did a video on that, and you can check using from this channel on test for normality in SPSS. So going by that, just for the sake of this, you should check on that. You can always click on analyze on the SPSS main analyze menu, then go on descriptive statistics, then click on explore. If you click on explore, you check on we have to use the time because this is the data or the specific data that we are interested on. Then remove it on the dependent list on the explore dialog box that is on your right hand side on the top. Then click on, we can check on the statistic, we can do with that, continue, then plots, we can check on normality plots, then also can check on the histogram. And we said that if a data is normally distributed, then there will be a bell-shaped histogram with maximum values on the middle and minimum values towards the end. Then we click on OK. And also through this, we can also check on using the Shapiro wheel, can also tell us whether the data is normally distributed or not. And in this case, we check on the significance level. So for this case, the significance level is 0.367. This shows that this is the data, the significant value here was higher than simply means the p-value here was higher than the significant value of 0.05, that is at 95% confidence level. So we were using the Shapiro wheel here. The data was normally distributed, and checking also on the plots, we find that the data were somehow close together, meaning they had no outliers value, or we didn't have any extreme values for that case. So we can just close that. Then let's go to the conducting a one sample t-test. So if you want to run a one sample t-test first, place your cursor on the Analyze menu on the SPSS main menu and click on Analyze. Then Compare Means to display this other menu where we have the means, then one sample t-test. So click on one sample t-test to display one sample t-test dialog box. So here we have two variables, x and time, and therefore our focus is on the time variable because this is the variable that we are interested on. We want to see whether the population mean, that is for this case, the population mean was assumed to be 45 minutes. So we will move on the test variable side, we move the time in minutes. Then our test value here will be 45 minutes because we say that for this particular group of it was assumed that they normally take 45 minutes playing with this particular object or item or called the toy. Then on the options, we can do it at 95% confidence level. Then we include cases analysis by analysis. Then click on continue. Then you can just leave it at that part. Then click on OK. So once we click on OK, the output view will be generated or will be activated, whereby here we have two tables. We have one sample statistics table, and the second table here is one sample test table. So by running this one sample t-test, we find that we have the mean that is generated is 40.73, standard deviation of 6.862, and standard error mean of 1.346. One sample t-test here give us a t-value of -3.172, a degree of freedom 25 up to the lower and the upper limits here. So what does this tell us? We're getting a mean of 40.73, but our test value or the mean population mean that we assumed was 45. This one now telling us we are having 40.73 mean, and the mean difference we are getting is -4.269, meaning that we got a value or a mean that is 4.269 less or lower than the test value. Significant level, we are finding that the data was statistically significant because the p-value here of 0.004 was lower than the significant value of 0.05 at 95% confidence level. Degree of freedom, you're getting 25. Degree of freedom is normally calculated by taking the total observations, and our total observations here were 26. I can just take you through. There were 26 entries. So we get degree of freedom, we take the total observation, then we -1 to get the degree of freedom. And that in this case, we get 25. Mean difference, already explained, is the difference between the test value and the sample mean of 40.73 we minus from 45. Then 95, we're getting the lower 95% confidence interval of the difference was negative or 7.04, and the upper was 1.50. So when we want to report this, we first transfer this data to the Microsoft Word by simply clicking on File. Then we come to Export. So once we want to export, then we can browse here where we want to export this data. Let me have it on the desktop. Then the file name here, we can give it one sample t-test results. Then we can save it at that point. Then we can click on OK to move that data. So once it has been moved, then we can come to our desktop here and check. Can come. So one sample t-test result is here. Then we can just double click on that and open this data. So you find all the output data. So this table, we are not really going to use it. We can do away with that. These other ones, you can also delete them. Then how do we report this? You can report this by saying that a one sample t-test was run to determine whether the time taken by the children to play with a specific toy was to determine the times taken by children to play with a specific toy. And it was found that there was the mean for that data was 40.73, lower than the normal mean of 45, or the normal or the test value of 45. Then we come and also indicate that the data was this data was normally distributed as shown by the Shapiro-Wilk, which found that the p-value was lower, was higher than, as we indicated on the other analysis that we did, was higher than the p-value here was higher than the significant value of 0.05, and also there were no significant outliers as indicated by the box plot, which I also explained before we conducted the one sample t-test analysis. The mean difference we found was 4.26 and t in bracket 25. So one sample t-test was trying to determine that time taken to play with a toy. 45 was different to normal time of 45. The time was normally distributed, as also assessed by the Shapiro-Wilk, which I did, finding that it was greater than the significant value of 0.05, and there were no outliers. Also, as I explained in the box plot earlier, the mean time which we found, that is the sample mean, was 40.73. Then there was a plus or minus 6.862. This is the standard deviation, and standard deviation simply tells us how far the values are spread away from the mean. So that's why we must have that a plus or minus 6.862, and was lower than the normal play time of 45. This is the test value, 45 minutes, and a statistically significant difference of 4.26. So 4.269, this is the value we have. It was statistically significant because the significant value or the p-value was 0.04. At 95% confidence level here, 95% confidence level, we find that one there. And lower was 7.04, and the upper was 1.05. This is the value that we get there. Then the t in bracket 25, this is a degree of freedom that we have. The degree of freedom values, then our t value was 3.172, and the lower we have that, then p was that. So this is how you can analyze and interpret the one sample t-test result for your data or for the specific analysis that you are doing under one sample t-test. So kindly, if you find this video very interesting, subscribe on using the subscription tab below, so that you can be getting more of this very informative video. Thank you very much for watching.